Okay, now let's do an example. So in this question, we have someone named Sparrow. Let's name him. Well, let's name him S. Okay. So he leaves home on his bicycle to post a letter. Okay. Now, don't worry about this kind of thing. Okay. Now, so when reading questions, yep, if the irrelevant, just cross them out. He start from rest. Okay. Now this tells me okay, when the time is zero, okay, his position, his displacement or distance will be zero. Okay. Also, its velocity will be 0 meters per second because it starts from the rest. Okay. And and he reaches the speed in 4 seconds. So when the time is 4, okay, his velocity is well, or speed is 4 meters per second. Now, then after that, okay, after that, okay, the velocity is constant. Okay, he doesn't accelerate anymore. He travels at a constant speed. So velocity is 4 meters per second in a straight line to a letterbox. Okay. Now he brakes at the letterbox, coming to a stop in 2 seconds. Okay. So, yep. So the last. Okay. Now, yep. Okay. So at last, okay, he stopped in 2 seconds. Means his change of speed. Okay, his final speed will be zero, and he changed from this to there in 2 seconds. So I just make up some sort of noise. Okay. Uh, then he posted the letter and returned home at constant speed at 8 meters per second. So that's forward. Okay. So that's basically just then he returns. He returns home at a constant speed of so 8 meters per second. Okay. Then when reaching home, he brakes, coming to the rest in 2 seconds. So when reaches home in 2 seconds of time, okay, his final speed at home will be 0 meters per second. Okay. Uh, okay, now down. Okay. So that's so when doing questions when doing those kind of questions, somehow try to rewritten, reorganize this in your own word. Okay? But make sure you have all the numbers calculated, written down somewhere. Okay? And also be careful with the word rest. Okay? When it starts from rest, means t equal to zero, the distance equal to zero, the initial velocity is zero. Okay? Now let's do question A. What is his average acceleration before he reaches his cruising speed of 10 meters per second? Yep, sorry, I made a mistake. 10 meters per second. 10 meters per second, yep. Yep. 10 meters per second in 4 seconds. Okay, sorry. Yeah, on the way. So we need to find, okay, so in this case, we are concentrating on the starting 4 seconds. Okay. We need to find its acceleration. So acceleration is basically the change of velocity divided by the change of time. So the change of velocity will be the final velocity. Okay, in these 4 seconds, the final velocity take away the initial. So 10 minus 0 meters per second divided by the time he spent 4 seconds. So if you do the calculation, I have 10 divided by 4, okay, meters per second divided by second. Okay. Then it will be 2.5 meters per second square. Okay. Down. Okay. Question B. What is its average acceleration as it breaks at the letterbox? So, yep, this part is the letterbox. Okay. Again, acceleration is change in velocity over the change in time. So now the trick part is here. Okay, it's the change in velocity. The change in velocity, the change in something would always be the final value take away the initial. So when we look at the braking, when the stopping braking to stop, okay, his final velocity will be 0 meters per second. Okay. Before he starts braking, his initial velocity will be 10 meters per second. So 10 minus 10, sorry, 0, 0 minus 10 meters per second over a period of 2 seconds. Okay. So I have minus 10 divided by 2 divided by seconds. Then I have minus 5 meters per second square. Question completed. Now, question C, we need to find the acceleration as it brakes when arriving home, so which is basically this part. Okay. Now, note the answer for question B is a minus 5. It's not 5. It's minus 5, means it's slowing down. Okay. And here is positive, it's speeding up. Here is slowing down. So, yep. C will be the same. Change in velocity or the change over time. Okay. Final take away the initial. Final is 0. Take away 8 meters per second over 2 seconds. I have minus 4 meters per second square. Okay. Now, question D. During which two parts of the trip did he accelerate negative? Okay. Basically, accelerate negative. Okay. So, well, if we can tell when he's breaking down, when he's so if you have a look, it's when he breaks down. Slowing down, when he slows down. Okay. Also remember, negative means travels in in the opposite direction. And also when he travels in opposite direction. Okay. Now, does a positive acceleration always mean that his speed increasing? Yes, I think so. Well, here is now the trick with this question is that means it's velocity increasing, it's not speed. Okay. Just remember, acceleration is a vector. So in order to calculate a vector, we need to use a vector value, which is velocity, not speed.